Okay, so remember 4, 6 is all the other trig functions. So this is tangent, cotangent, cosecant, and secant. Yeah, we got introduced into tangent. Remember, tangent has asymptotes, and they occur every period. So we find the A, we find the B. The period is pi over B instead of 2 pi over B, like with sine. And then we set our bx minus c equal to negative pi over 2 and positive pi over 2, which was here. And then we find our middle two asymptotes from the one on the left. We subtract the period from the one on the right. We add the period. Those are your 4 asymptotes. So remember, your goal there is to get 4 asymptotes. And then you're going to get 3 curves. And you would do that by finding the halfway point in between. That's your x-intercept. And then eyeball the quarter point and the 3/4 point. And that's where your negative A and your positive A fall, or your amplitude. And then tangent goes up to the right, down to the left, so it follows that pattern. All right, so the good news is the process of cotangent is almost exactly the same. There are 2 changes between tangent and cotangent. One is the initial shape of your curve. So notice that cotangent goes up, left, down, right. That's one major difference. The other major difference is what you set your bx minus c equal to. So if you think about your cotangents as you move around your circle, right, tangent here was 0. Tangent here is undefined. Here it's 0. And here it's undefined. So where is cotangent going to be undefined? At 0 and pi. So instead of setting it equal to negative pi over 2 and positive pi over 2, we set it equal to 0 and pi. Everything else is exactly the same. So I'm going to take the bx minus c, set it equal to 0. The bx minus c, set it equal to pi. I'm going to solve for x. Those are my middle 2 asymptotes. From the one on the left, I'm going to subtract the period, which is still pi over b. To the one on the right, I'm going to add the period, which again is still pi over b. And then you plot your 4 asymptotes. You find your point halfway between. You do your quarter point, your 3/4 point. You do your amplitude. And then the difference between tangent and cotangent is I go up on the quarter point and down on the 3/4 point.
I have a question.
Mm-hmm.
What does it say under the tangent?
Cotangent undefined. UD undefined. The bx minus c, or on the unit circle?
The bx minus c.
So you're trying to figure out what would make it undefined, because that's where an asymptote goes, right? So if you go around your unit circle for cotangent, cotangent's going to be undefined at 0 and at pi. So that's why I use 0 and pi. Whereas tangent's undefined at pi over 2 and negative pi over 2, so those are the ones you use. I mean, it's typed up on this slide, but it's kind of the same thing we just talked about. So we set it equal to 0 and pi. And then you're going to find the x-intercept at the midway point between those. And then you're going to do your quarter point and your 3/4 point. And on that one, you're going to plot positive A because you're going to go up on the left. And then negative A, you're going to go down at the 3/4 point. And again, with these, just like with the tangent, you should have 4 asymptotes and 3 curves. All right, so is yours negative? Okay, make it positive. I don't know why I tried to confuse you before we even start. Y equals cotangent pi over 2x. We're going to graph this one first. So again, the biggest piece of advice I can give you is really be careful with this stuff, because if you graph this whole thing as though it's tangent, it's wrong. And you're going to get them all mixed in on your test. So you got to make sure, like I've seen people go through all this work and then graph the wrong function, whether it be sine and cosine or tangent, and then you lose all those points. Don't do that, okay? Make sure you're really careful. So we know cotangent's going to go up, left, and down, right. As soon as I see that, I can plot that. I can give myself a little note, whatever it is, to know what it's going to look like in the end. So then my A is 1 because there's nothing in front of cotangent, which means that's going to be my amplitude. The b is what's in between the cotangent and the x, which is pi over 2. And the period is pi over b, or pi over 2. And then I'm going to keep change flip. The pi's cross, and I just get 2. So my period is 2. Now I'm going to take the bx minus c, which is this whole thing here, and I'm going to set it equal to 0. And I'm going to set it equal to pi. And I'm going to solve for x. So dividing by pi over 2 is the same thing as multiplying by 2 over pi. And I get x equals 0. Divide it here. Multiply by the reciprocal. And I get 2. These are my center asymptotes. From the one on the left, I'm going to subtract the period. Which is 2. From the one on the right, I'm going to add the period. And I get x equals negative 2 and x equals 4. Those are your first and last asymptotes as you move from left to right. So I've got negative 2, 0, 2, 4. Those are going to be my asymptotes. I'm going to find the points halfway between. So halfway between negative 2 and 0 would be negative 1. Halfway between 0 and 2 would be 1. Halfway between 2 and 4 would be 3. And those are your x-intercepts. I'm going to eyeball my quarter point and my 3/4 point. And my amplitude is 1. So now at the quarter point, I'm going up to 1 because this is cotangent. So it starts up, goes down, starts up, goes down, starts up, goes down. And then I'm going to connect those points. Again, 4 asymptotes, 3 curves. Okay, so A was 1, which is your amplitude. B is 1, so the period's pi. Then I did x plus pi over 4 equals 0. X plus pi over 4 equals pi. Subtracted the pi over 4. I get x equals negative pi over 4. Subtract the 4, and I get x equals positive 3 pi over 4. Those are the middle two. Then from the one on the right, I'm going to subtract the period. So minus pi becomes minus 4 pi over 4, and I get negative 5 pi over 4. And then add the period, add 4 pi over 4, and you get 7 pi over 4. So that's where I'm at so far. I plotted it. I graphed those asymptotes. Questions?
In the first step, y is equal to 0 and 1 and then equal to
Because that's what you set cotangent equal to.
always.
Always. That's where cotangent's undefined.
Wait, what did you ask?
Okay, so now I gotta find the points in between, which is a little bit less obvious because they're not whole numbers. But you could either, obviously, some of you can figure this out. But the rest of you can use negative 5 pi over 4 plus negative pi over 4 and divide it by 2. So I'm going to find the midpoint by adding them and dividing by 2. So I'd get negative 6 pi over 4 over 2, which is negative 3 pi over 2, multiplied by a half, and I get negative 3 pi over 4. Halfway between negative pi over 4 and 3 pi over 4 would be 2 pi over 4, which is pi over 2, divided by 2 is pi over 4. And then halfway between 3 pi over 4 and 7 pi over 4, 10 pi over 4, 5 pi over 2 times a half, 5 pi over 4.
Is there an easier way to do it?
Nope. Sometimes the numbers are just yucky. Those are your x-intercepts. And then we want to eyeball the quarter point, the 3/4 point. And your amplitude this time is 2. This is cotangent, so we're going up to 2 on the left, or the quarter point, down to negative 2 on the right, or the 3/4 point. And then again, if it was negative, it would be the reverse. If there's a vertical shift, we would just take it at this point and shift everything up or down, whatever the points are.
Do we have to show the work from the midpoint?
No, sometimes you can do it in your head. Yeah. All right, so the good news is cosecant and secant. Well, good if you're good at sine and cosine. It's really just like 2 steps more than sine and cosine. The beginning process is exactly the same. So cosecant is the reciprocal function to sine. So when I graph cosecant, I actually graph sine, and that's what this curve is going to be. So this would have been sine here. And then everywhere sine is 0, if I flipped it, it would be undefined. That's where the asymptotes come from. And then if I flip what's happening on each point, you would see it bounce off those curves. So the cosecant curve is actually what was blue, what's now pink. This curve, okay? But the sine curve gets you there. So you're going to graph sine. Everywhere there's an x-intercept, you're going to actually plot an asymptote. And then everywhere there's a max, you're going to put a 0 and flip it up the other way. Everywhere there's a min, you're going to put a point and flip it down. So again, it just goes off of like the little hills and the valleys of your sine and cosine curve, of your sine curve. So you're going to do the same thing we did with sine. We're going to do A, amplitude, B, period, quarter point, half, 3/4 point, plot your key points, draw your curve, and then find the asymptotes, and then the curves to bounce off. Your normal curve for sine is like this, right? Which gets you 1, 2, 3 asymptotes. And 2 curves. You still need 1 more asymptote. So you can choose to either bring your curve over to the right on that side or continue your curve onto the left. It doesn't matter to me, as long as you add at least 1 more asymptote and 1 more curve. So whether that be to the right of your sine or the left of your sine, it does not matter. And like I said, I'm not going to make you find an exact point. You can kind of eyeball where that curve would hit. For secant, it's the reciprocal of cosine. So I do exactly what I would normally do with cosine. I'm going to graph my cosine curve. The difference is that you need more than just one period these times because you still want 4 asymptotes and 3 curves. So for both of them, for secant and cosecant, 4 asymptotes, 3 curves. So we're going to find our exact 5 key points that you normally need to find. And then you don't need to continue to make them exact beyond that point. I'm going to let you kind of estimate where the continued curve would go, as long as you're going to end up getting 2 more asymptotes and then 3 curves in total. So when you graph cosine, it would look like this. You're going to basically, the easiest thing to do is just drop down the curve on both sides, and that gives you your additional asymptotes. So from the original one you got, God bless you, the 2 in the middle, and then you can just drop down the sides. And then from sine, you're going to just duplicate your curve. Same thing, 4 asymptotes, 3 curves.
When do we know to do the half ones?
I mean, it doesn't, for me, cosine's easier to do that. It doesn't mean you have to, you can do a whole nother one to the right. It's the same thing. Your end goal for secant and cosecant is 4 asymptotes and 3 curves. However you get there is up to you.
But doesn't that equal more than 3 curves then?
No, if you normally graph cosine, it looks like this, right?
Mm-hmm.
That's what it would look like. From there, you get those 2 asymptotes, right? And 1 full curve. So you'd need to get 2 more points where it crosses the x-axis to get your other asymptotes, and then you'd have 3 complete curves. Okay, so this is just variations. What happens when it stretches out? When it shrinks, okay, if your period is bigger, your period is smaller, obviously it would just happen more frequently. So if you were to look at this on a graphing calculator, you would see a lot more curves if your period was smaller than, like, let's say it's 2 pi. That's the only difference, okay? And then you could see a vertical stretch. So you see here the amplitude's 2, which means it doesn't start till it hits 2, whereas here it's 1, so the lowest point is 1 on this. All right, so the first thing I would say to do is look at this and say what reciprocal what reciprocal function are you doing? What's reciprocal to cosecant? They will look like this. It will just say graph this. You have to know that this means graph first sine of 2x, and then I'm going to do the reciprocal function, okay? So again, the test will just say y equals, probably not something this simple, but y equals cosecant of 2x. So I go back to what we did in 4-5. A is 1, which is your amplitude. B is 2, and the period is 2 pi over b because it's sine. So it's 2 pi over 2, which is pi. Then I do my quarter point, my half, and my 3/4. The first one's going to be at 0 because there's no phase shift. The last one's going to be at pi. That's the period. With me so far? Yeah? Okay, so now I'm going to my graph. Ah, whoa. Okay, and amplitude is 1. So what's the parent function that I'm graphing? Sine. Where does that start?
0.
At 0, 0. So my point's going to go here. It's going to go up to 1, down to 0, down to -1, up to 0. And my sine curve's going to look like that. So then everywhere there's a 0, if I flipped it, it'd be undefined. That's why the asymptotes happen there. How many asymptotes do I need? 4. I need 1 more. So I'm just going to duplicate this back over here. Again, I don't need it to be exact. I'm kind of just like eyeballing, but I want the spacing to be the same. So I'm going to bring this down here. That's not the same. I'm going to bring this down here so it looks like that. And I'm going to do my last asymptote. And then everywhere there's a max, I bounce the curve off of that point. Everywhere there's a min, I bounce the curve off of that point.
So you don't need an exact point for the fourth asymptote?
Nope. And then technically, this is actually not even part of my graph. So you'll sometimes see the like sine curve dashed. You'll see it lighter, okay? You could erase it if you want. You can use colored pencils on this test. I like this test because it gets pretty and colorful. So if you wanted to use like a lighter colored pencil on one curve and then your answer in the other, that's fine too.
And is it okay if it's just a regular line?
And then it's, yeah, there should be some sort of indication. So you need to make your cosecant either darker or erase a little bit of your sign, but there should be some sort of indication that they're different. So on notability, obviously it's easier because you got multiple colors, but on a or pencil and paper test, like I said, I'll crack out the colored pencils, or you'll just make sure that you can bring a highlighter if you want to highlight your answer, whatever it is. Questions?
Are we gonna do curves only in chapter 4?
Yes.
Okay.
Yeah.
I was just wondering if we like still like if we are gonna use not use it, but like have it in another chapter.
So it references it again later, but not like this.
Okay.
Yeah. And in calc, certainly,
Nice.
but not again this year. Oh. So the biggest mistake people make is like going through all that work and then graphing the wrong curve at the end. Don't do that. Okay? Make sure you're doing these really carefully. So now this one, which again, probably your instructions are different, right? It would look something like this. It would not look like what it says, which is to graph the cosine and then that. It's just going to say straight this. You have to know that secant is the reciprocal of cosine. So I'm going to first graph cosine, and then I'm going to go back in and graph it. So it's the exact same thing. All the parts stay the same. The only thing that changes is the trig function inside. So it is 2 cosine 2 pi x, which means my A is 2 and my amplitude is 2. My B is 2 pi, and the period is 2 pi over 2 pi, which would be 1. There's no phase shift. So I'm going to find my quarter point, which these should be easy, right? Because 1 times a quarter is 1/4. 1 times a half is 1/2. 1 times 3/4 is 3/4. First point is 0. Last point is 1. I'm going to mark those points again. 0, 1/4, 1/2, 3/4, God bless you, 1. Amplitude this time is 2. And now this is cosine, so where do I start it? Good, at 2. Then I come down, down, up, up. Draw your curve. Everywhere there's an intercept is an asymptote. I only have 2. This time I'm missing 2, and this is where it's easier to just drop it on either side. You can do a complete one on the other side, doesn't matter. But in my opinion, it's easier just to drop the half and the half. And then everywhere there's a max, gets a curve pointing up. And everywhere there's a min, gets a curve pointing down. So keep in mind again that when you're checking these on a graphing calculator, you are not going to see the cosine curve. You are just going to see the like parabola shapes. You won't see the asymptotes either. So we're not going to go through like graphing them full out all the variations, but think of how this could change. If it was a negative amplitude, everything would be flipped upside down. You would just graph negative sine instead of, or negative cosine instead of positive cosine. If there was, and this is where it gets a little bit confusing, if there's a vertical shift, my advice is to graph it exactly the way it is right now. Find your curves, or actually go ahead and draw your curve, and then shift it after you find your asymptotes, because it's going to be harder to find your asymptotes. So shift it, if you're doing a vertical shift, after you find your asymptotes. So everything would just get shifted up 1 in that case. This would come up 1. This would go up 1. So the vertical shift gets a little crazier or not crazier, but a little bit more complicated to find your asymptotes. So you want to shift it after you find your asymptotes if there is a vertical shift. Questions on anything we talked about today or yesterday? Anybody still copying that down?
Yeah.
Okay. All right, so this just puts all 6 on the same thing. Obviously, you've got sine, cosine, tangent, cotangent, secant, and cosecant, right? So test-wise, you will get like 1 of sine or cosine. You're going to get probably the reciprocal function from secant or cosecant, and then you're going to get tangent or cotangent. So there'll be 3 total graphs on your test, okay, where you've got to go from start to finish. You won't get all 6, okay? It will take you way too long to do everything else on top of this. But you will see something like that, like either a sine or cosine. If you're going to get the sine, then you're going to get the secant, because I want you to do the cosine. If you're going to get the cosine, then you're going to get the cosecant, because it'll force you to do and then tangent or cotangent, you'll get one or the other. Okay? But it will depend on your version. So just keep that in mind that you got to be ready for all of them. So the homework, again, has all these graphs. Okay? It is, again, a PDF. You need to make sure you're showing me your work. You need to make sure you're showing me the key points and all that good stuff. If it's the cosine and the cotangent and the tangent, you need to make sure you're showing me the asymptotes and all that stuff. Okay? It's really important that you learn how to obviously graph these by hand.
Amplitude has to be positive, right?
Amplitude is always positive. Yep.
So what's an A if it's just the amplitude?
So the A could be positive or negative.
And on the test, will it ask for A and M?
No, it will only ask for amplitude. It's going to ask for amplitude, period, key points, or asymptotes.
Mm-hmm.
And then, what am I missing?
So
And then the graph.
if it was like -2, amplitude is
2, but the negative tells you flip it upside down.